Okay, I think we are set to begin. Let me open up the chat. Hello. Thank you, Kareem. Anything, any questions about them? Okay, so today's live stream is about May June 2024. This is an M1 exam. This variant is 4.2. Let's begin quickly. This is a cyclist and bicycle have a total mass of 72 kgs. The cyclist rides along a straight horizontal road against a total resisting force of 28 Newton. Okay, the resisting force is 28 newtons. The total work done by when the total resistance increases from 8 to 16 while traveling a distance of 100 meters. Okay, so I'll just use the energy formula work done by driving force. Tangent K, tangent P, plus work done by resistance. So work done by driving forces, that's what I want to find out. All M V square minus square. Cos 0 plus work done by resistance is 28 into, okay, cos 72 is 36, 18 square minus 16 square minus 8 square plus 2800. 9712, and that should be the correct answer. Yes, correct answer. Moving on to question number 2. A particle moves in a straight line at time t seconds after it has velocity of this when the set of values of t for which the acceleration of the particle is um, positive. I will encourage you to solve the paper first, and then it's going to be more productive for you. Find the set of values of t for which the acceleration is positive. So acceleration is 44 minus 12t. 44 minus 12t is positive, so that means it's greater than 0. 44 divided by 12, 11 over. So t is less than 11 over. Find the two values of t for which particle p returns, which p returns to O. So returning to O means that the displacement is 0. I don't have the displacement function right now, so I'm going to integrate and find the displacement function first. So that becomes s because I've integrated plus c. So I realized that at time t seconds after leaving a point O, so it's left O. That means it was at O when t was 0. S was also 0, so s equals 22 0 minus 2 0 minus 36 0 plus c. So s was also 0, c is 0. Therefore, so s is 22t square minus 2t cube minus 36t. When does the particle return to O? When the displacement is, okay, I see a t common, so 22t minus square minus 36. So either t equals to 0 or this equals to 0. This is a quadratic minus b plus minus b square minus 4ac over to a. Okay, let's put that on my calculator. Two 22 and 9 and 2, so it returns 2 and 9. Okay, I don't know what the journey looks like, but okay. Moving on, question number 3, for coplanar forces of magnitudes p newtons. Which part? B. For coplanar forces of magnitudes p newtons, 10 newtons, 6 newtons, and 2 newtons act at a point in the direction shown in the diagram. It is given that the forces are in equilibrium. Find the values of theta and p. So up equals to down. There's only one force that's up. P. What are the down forces? There's a down force here, so that's 10 sine 25. The down force here, that's 2 sine 40. 2b of which part? 2b of this paper. It says particle returns to O. You return to O when your displacement is 0. That's what I've tried to find out. So I've integrated the velocity function. Once I integrate the velocity function, I find the displacement function, and then I put in s equals to 0. And then this one is, this part of should be 16 cos 40, since this angle cos theta, since this angle is defined this. Okay, that's up equals to down, and then I have left equals to right. Okay, left I have 2 cos 40, and then I have 16 sine theta, and for right I have 10 cos 20. Okay, I think this one is convenient in terms of finding theta, so I'm going to find theta from here. Twenty-eight 28.07 is 28.1. I plug in that here. Do I get 2 sine 40 and 10? 19.6. 19.6, the value of p. Yep, those are the correct answers again. Question number 4. A car has mass of this. When the speed of the car is v, the magnitude of the resistance to the motion is kv square. If k is a constant, the car moves at a constant speed of 24 up a hill inclined at an angle of alpha to the horizontal, where sine alpha equals to 0.12. At this speed, the magnitude of the resistance is 480. Find the value of k. Okay, so the acceleration is 0, so F equals to ma. Okay, the driving force, the magnitude of the resistance to the motion is kv square. Okay, that's not, I think that's simple then. The magnitude of the resistance is kv square. Kv square should equal 480. K and 24 square should equal 480. K equals to The trick with M1 is to, you deleted your message, but the trick with M1 is to just start from the beginning. What a lot of people have trouble with is identifying uh, what topic it is. So always first filter out the data, see if you have an energy problem or just um, uh, Newton's laws problem and so on. Find the power. So power has the formula of force into velocity. Okay. Since I have an acceleration of 0, can I say that the driving force minus the resisting force equals to ma? The driving force is also 480. The power should be 480 into 24. No, I suggest that you start from the beginning. 11,520. You will certainly find easier questions at the beginning. I messed something up. Okay, it's going up a hill. I didn't realize that. Going up a hill. So there is the weight as well. Minus 14,000 sine alpha equals to ma. Sine alpha is 0.12. 160. Power is force into velocity. By 1840 watts. The car now moves at a constant speed on a straight level road. Given that the car's engine is working at 54 kilowatts, find this speed. Again, acceleration has to be 0. This time the power is 54,000. Okay, so the driving force should be 54,000 divided by the speed. 54,000 over V. Now it is given instead, so this information is not relevant. I'm going to go back to kV square 5 over 6. V square is the resistance and equals to ma. A 0. 54,000 V over V equals to 5 over 6 V square. 54,000 multiplied by 5 multiplied by 6 divided by 5 equals to V cube. Cube root of answer gives me 40.2. Correct. That's the correct answer. Okay, then we have question number 5. A particle of mass 0.8 kg lies on a rough slope which is inclined at an angle of 28 degrees. To the horizontal, the particle is kept in equilibrium by a force of magnitude 3 newtons. This force acts at an angle of 35 above the line of greatest slope. The coefficient of friction is and the least and greatest possible values of T. So the idea of least and greatest possible values is simply that you decide what direction friction is pointing to. Okay, I'm going to first solve the rest of the forces and then draw the friction for you. The friction could be facing either side, whether point where the particle is on the point of moving up the plane. So friction is going to point down, and when it's pointing, when it's about to move down the plane, the friction is going to point up. Okay, first let's resolve this. This is 80 cos 20, 80 sine 28 and 80 cos 28. That's r. Resolve that. T sine 35 and t cos 35. Okay, mu is 0.2. First, let's assume that friction is pointing that way. Okay, so up equals to down. So up is r plus t sine 35. And those are the up forces. The down forces are 80 cos 20. Then left equals to right. So 0.2r plus 80 sine 28 equals to t cos 35. Okay, that's one set of equations. I will have to solve these simultaneously, so I'm going to substitute r from the first equation and put it into the second equation. Okay, so r is basically 80 cos 28 minus t sine 35 from the first equation, that multiplied with 0.2. Yes, there are two scenarios. I'm going to do that. I'm going to first find one value, and then I'm going to change the scenario other value. It should be 8 and not 80. I made this mistake earlier. 0.2 into 8 cos 20 into 8 is 0.6. Okay, and that equals to, I get 1.22 t cos 35 equals to all of this. You could essentially convert everything to a decimal, make your life easier if you want. I think I've kept it a little more complicated because I'm looking for exact values, so absolutely unnecessary. You could take 4 decimal places everywhere and get done with those calculations. I would just show you the substitution and solve then everything on a calculator. 1.6 cos 28 plus 8 sine 28. 5.26. Like if that's one of the values where we know if we're doing correctly. No, I've made some error. 0.6 or t sine 35. Oh, this 8 as well. And I've forgotten the other side. I've solved incorrectly, which is why I was telling you that it might be a little more challenging to solve like this. Um, what I get is t cos 35 plus 0.2 t sine 35. That's what I made a mistake on. Okay, now dividing the two would give me the right answer. 5.53. Yeah. Okay, then in the other case, what I'm going to say is that instead of having the friction here, you'll have the friction on the opposite side, where the particle is about to slide down the plane. So that's going to be 0.2r. The up equals to down will not change. So your substitution should also remain the same. The other equation will change. You have now 8 sine 28 equals to t cos 35 minus plus 0.2r. Okay. So again, taking the substitution from equation number 1, I get r equals to 8 cos 28 minus t sine 35. All other things have remained the same. I've made the substitution now. T cos 35 minus zero point 0.2 t sine 35 plus 1.6 cos 28. So I have 8 sine 28 minus 1.6 cos 28. And then when I take t common, I have cos 35 minus zero point 0.2 sine 35. Okay. I'm writing t as what kinematic lectures are you talking about? There might be old videos. Yes. I haven't uploaded the new ones. Okay, question number 6. It says three particles ABC of masses 5 kg, 1 kg, and 2 kg. 5 kg, 1 kg, and 2 kg are at x, y, and z. Okay. A particle A is projected with a speed of 6 towards particle C towards particle B, which is at rest, and at the same instant C is projected uh, towards B with the speed of V. But since it's in the opposite direction, it's minus V. In the subsequent motion, A collides with and coalesces with B to form particle D. Okay, so mass into velocity plus mass into velocity before impact equals to after impact. So let's call that 6V right now. So it's going to give me 5. Okay, so the combined particle D now has a velocity of 5. It has a weight of 6. It's now going to collide with C. C had an initial velocity of minus V. Okay, and they combine to form particle E. So 2 into minus V equals to 8E. 30 minus 2V equals to 8E. And I think I have my answer. 30 minus 2V over 8. I factor out a 2, and that should give me 2 in minus V over 8. So 2 times 4. Okay, the total loss of kinetic energy of the system due to the two collisions is 63 joules. Use the result from part A to show that V equals to 3. So for the first collision, I had uh, initial K as half m mass of 5 and it had a speed of 6. Okay, 36 into 5 divided by 2 gives me 90. Okay, there was no initial KE for the other one, so it was half 1 into 0 square, so that's 9. Okay, the final KE after the first collision is half this 6 as the combined weight, but the speed has reduced, so 90, and this turns out to be 6 to 25 divided by 5. The loss in KE recorded was 90 minus 75, which was 15. Okay, so that's 15 compensated loss. Okay, then for the second collision, I now have an initial KE of half into 6 into 5 squared, 75. And then I have a final KE, and then there was the other particle as well. So it also had a speed, which was half into m into v squared. That was 70, no, not 70, 75 plus v squared. Final KE was half into 8 into 15 minus v over 4 squared. Okay, so since 15 was already lost, can I say that half into 8 into 15 minus v 4 squared minus 75 plus v squared is equals to minus 63 plus 15, which is compensated loss. Okay, so the net remaining loss was minus 48. Now let's try to solve this. 450 minus v over 4 squared minus 75 minus v squared. So that gives me 4 to 25 minus 30v plus v squared over 16 minus 75 minus v squared minus 48. So 4 into 225 is 900 minus 120v plus 4v squared. That's 16 into 75 minus 1200 minus 16v squared, and then 16 gets multiplied on the other side as well. So 7. So I have 4v squared minus 16v squared minus 12v squared minus 20v, 900 minus 1200 minus 768 gives me minus 1068 equals to 0. Let's put that in a quadratic and see if it solves the problem. I think I've made a calculation mistake somewhere. Final minus in 900. Make the calculations a little easier. Minus 63 plus 15 minus 8. So 225 minus 30v plus v square, 300. 192 minus 3v squared, 1. Yeah, I think I made a calculation like earlier. So v equals to 3 or v equals to minus 13. Okay, the distance between, it is given that the distance xy is 36 meters and the distance yc is 98. Find the time between collisions. When A starts off, it has a speed of 6. It has to travel a distance of 36 meters. Its acceleration is 0. I want to find the time, so 36 equals to ut. Half at square is not there because it's 0, so t equals to 6. During that period, what's going to happen is that C was coming back in the reverse direction, so it had a speed of minus v, and v came out to be 3, so u equals to 3. It was traveling for a distance of 6, so it was already at a distance of 18 meters. So this distance between y and z, 18 meters of it was already covered. How much of it was remaining? 80 meters. In those 80 meters, both were moving. D had a combined speed of 5. Let's say it had to travel a distance of x meters in time t. On the other hand, C was coming forward. It had already traveled a certain amount of distance. It had to travel the remaining distance, t minus x, and t was again t. S equals to ut. S equals to ut. And then I substitute 8t minus 5t equals to 3t. 8t equals to 10t. 8t, sorry. T equals to 10. Okay, then it says find the time this between the which A is projected from X and the instant that E reaches C. Now E is formed when D and C collide. Okay, at what point have they collided? They've collided at a distance of 50 meters. While this total distance was 98 meters, which means that there was still 48 meters to return to uh, Z. The combined particle has a speed of 15 minus v over 4, which was 3 actually. So let's find out the speed. So 48 equals to 3t plus 0, t equals to 16. So what's this, the total time? 16 plus 6 plus 10, which is 32 meters. Okay, then question number 7. Question number 7 says two particles, P and Q, of masses 2.5 and 0.5 respectively, are connected by a light and extensible spring that passes over a small fixed pulley at the top of the plane, inclined at an angle of 30 degrees to the horizontal. Particle P on the plane and Q hangs on the pulley such that the level of Q is 2 meters below the level of P. Okay, the particle P is released from rest and slides down the plane. This is unusual. It slides down like that. The plane is rough with coefficient between 0.2 and the plane P. Find the acceleration. 5t. So the first equation that I have is t minus 5 equals to 0.5a. That's simple. For the other equation, let's resolve the weight first. So that's 25 sine 30. Okay, so that's driving down the plane, 25 sine 30. What is resisting it? There's tension resisting it, and there's also friction resisting it. Okay, so frictional force is going to be 0.2 into R. R is going to be 25 plus 30 equals to 2.5a. We cancel that with t. Let's see what the remaining thing is. 25. I'm getting acceleration is 1.06. Okay, I hope that's the correct answer. That's the Look at the last part. Okay, part B says use an energy method to find the speed of the particles at the instant when they are at the same vertical height. Okay, so I know that friction was pointing up, point to R, and there was R here. Okay, when they're at the same height means that there's some random number level here where they are meeting. Okay, what I can say from this is traveling a distance of x. Okay, now what is the connection between this and that? Let's just write down our numbers first. Work done by driving force equals to change in k, change in p, plus work done by resistance. Okay, so work done by driving force is this one, driving force. The half m is together, and we have v square minus 0 square. The p is changing. Okay, so let's assume that q is going up, so that's 0.5 into 10 into x. Okay, q is going down. Okay, 2.5 and 10, and it's going down by a distance of 2 minus x. That is what I can be sure of. Or let's make it simpler. I can say that since this is traveling a distance of x, this distance should also be x. Now, if something is traveling a distance of x, then the change in PE, should be x sine theta. Okay, so I'm going to write x sine theta. Okay, this rope moves up by x and this rope moves down by x as well. So P is traveling downwards by x sine theta. Okay, I know that if P is traveling down by x sine theta, okay, that is what I know. Let's see. Work done by resistance is again, then let's see what our resistance was. This was the frictional force, 0.225. That's 5 cos 30, that's 5 root 3 over 2. That's frictional force, and it's also traveling a distance of x. Now I have two unknowns in my question. What is the problem? So let's figure out what x is. Can I say that x plus x sine 30 should equal to x1 plus sine 30 should equal to, so that's x 3 over 2 should equal to, and x is therefore 4 over 3. Okay, because they together have to cover up the 2 meters that are between them. So half v squared 5x plus 5x. X is basically 4 over 3 now, minus 2.5, so that's 25. And I have 4 over 3 sine 30 plus 5 root 3 over 2, 4 over 3. Sine 30 is also half. Let's see if we get the correct answer. That's 20 over 3 minus 3 over 3. And that's 10 root 3 over 3. 1.5 v squared. So I get 20 over 3 minus 50 over 3 plus 10 root 3 over 3. Divide by 1.5, multiplied by minus and root of constant. So I'm getting v as 1.8. Let's check if that is the correct answer. Yes, that is the correct answer. That's the end of this exam. I will see you with another paper in the next class. Thank you for watching.
Welcome to Edge Learning, where we are changing dreams into success stories. Let's go! At Edge Learning, we offer courses to help you excel. Whether you're preparing for the SAT, aiming for IBA and LUMS, need O and Alevel tuition, or IELTS coaching, we have the right program for you. Forget about boundaries. We offer learning anywhere, anytime. Our expert tutors provide personalized attention in various batch sizes and one-on-one sessions, along with pre-exam review workshops to ensure you perform your best on test day. Join us at Edge Learning and take the first step towards turning your dreams into reality. So what are you waiting for? Register now or call us.